Welcome! This video is proudly brought to you today by the WizIQ AI team, founded by Sajit Kesavan. For the last few years, we've mostly used artificial intelligence as a very smart search engine. You type a question into a chat box, it gives you a text response, and you still have to go do the actual work yourself. Agentic AI changes that dynamic. These systems act as digital workers that can log into your company's software, handle complex tasks, and finish projects on their own. To understand how this works, picture hiring a brand new digital intern for their first day at the office. Right now, they have potential, but they aren't useful yet. For this intern to actually help your team, we have to provide them with 6 specific core foundations. Setting up these 6 elements is how we turn a basic computer program into an independent problem solver. Every new hire needs access to your company's digital filing cabinets, the databases, the chat apps, and the private folders where your software is built. Usually, giving an AI this access required engineers to write dozens of separate, complicated digital keys. That brings us to our first building block. As you can see in this report excerpt, the Model Context Protocol, or MCP, is an open standard designed to solve this integration challenge. Think of it as a universal corporate ID badge. With this single badge, our digital intern can instantly connect to your databases or review team messages. No one has to build a separate custom connector for every single piece of software. By creating one standardized way to plug into the network, MCP clears the primary technical hurdle that used to keep AI isolated from your actual company data. Now that they are in the building, we have an issue with memory. Standard AI suffers from cognitive amnesia. The moment you close the chat window, it forgets everything you just talked about. To fix this, we give the intern short-term memory, a sticky note on their desk for immediate steps so they don't lose their train of thought. For knowledge sticking around for months, we use long-term memory, or vector databases. This permanent filing cabinet stores your style guides and formatting preferences. Even with perfect filing cabinets, an AI cannot look at every single document in the building at the exact same time. This brings us to the context window. You can think of the context window as the physical size of the intern's desk. It is the hard limit on how much information the AI can actually focus on at any one moment. If you take a 5,000-page instruction manual and dump it all onto a tiny desk, the workspace overflows. Looking at this architecture report, we see what happens. Models experience a lost-in-the-middle phenomenon, where they overlook critical instructions buried in the pile. To prevent this, the AI is programmed to be tidy. It summarizes large files and brings only the most relevant, smaller chunks of information onto the desk before it starts working. Keeping this workspace neatly managed ensures the intern remains accurate and doesn't get confused or start making up facts during a complex project. Our intern has their ID badge, their files, and a clean desk. Next, we have to look at how they actually think through a problem. Instead of guessing, an agent relies on the agent loop, a continuous 4-step workflow. First, it perceives a request, then creates a step-by-step plan. Next, it acts to fix the issue and observes the result. If it fails, it loops back to the start to try again. This cycle of trying, watching the result, and adjusting is what gives the AI true autonomy, the ability to realize it made a mistake and course correct without you having to help. Even a brilliant thinker is limited if they are locked in an empty room with no tools and no internet. That is why we need tool use. This is the equivalent of handing our intern a calculator, giving them a web browser, and handing them the corporate credit card. Once tools are unlocked, the AI independently checks live flight prices, calculates the best route, and uses a booking program to actually purchase a ticket. Adding these external functions upgrades the AI from a sealed reference book into an active participant that can finish real-world tasks. Giving an automated system the ability to write code and click purchase creates a risk. A simple misunderstanding could lead an AI to accidentally delete the live software your customers rely on every day. To prevent that, we use sandboxing. As this architecture manual describes, a sandbox is a secure, isolated replica of your office software. Think of it as placing the intern in a fake, identical replica of your office where they can practice. Inside this digital bubble, the intern can test code and make as many disastrous mistakes as it wants. The sandbox restricts the intern's access, so those errors never touch your live company systems. Without this secure testing environment, letting an autonomous agent loose in a company network would be far too dangerous to try. When we bring these pieces together, the ID badge, the memory, the workspace, the workflow, the tools, and the safety bubble, the system is complete. Artificial intelligence has reached the point where it no longer just offers advice. It can now carry the operational weight of a project on its own. The days of doing every manual step yourself are ending. Autonomous agents are now ready to take over the heavy lifting. Thank you for watching. On behalf of Sajit Kesavan and the WizIQ AI team, we hope this guide helped clarify the future of digital work. Please hit the subscribe button so you don't miss our next breakdown.